SF50 Real World Flying. This is the second episode of Circuit by Circuit, and I heartily congratulate everyone who had the desire to come back and learn more details about the SF50 electrical system. Let's move over to the circuit breaker panel on the Copilot side. The first one is D1, labeled CAPS B. It is an emergency bus system, and the PIM simply labels it CAPS. Jumping ahead, just to stay with the parachute system, the CAPS A breaker is located on the aft circuit breaker panel. The PIM says it's powered by the battery 1 hot bus. Now remember, this is why you can pull CAPS in a cold airplane on the ground and have the rocket fire. Having the BAT switch off makes no difference. D2 is labeled Standby ATT, or Standby Attitude, and it's also an emergency bus system. Now, this is not power for GTC1, as we've already discussed those circuit breakers. D2 protects the circuit when the unit known as GTC1 is operating in the Standby Attitude and Airspeed mode. And here's what the PIM says. Quote, 28 volt DC for remote MD302 standby attitude module operation is supplied through the 1 amp standby attitude circuit breaker on emergency forward panel 1. D3 is GTC1A, and it's an emergency bus circuit. The PIM names it GTC1 main. We discussed GTC1B earlier when covering circuit breaker C9. Now here is a bit more detail from the PIM. Touchscreen controller 1, 28 volt DTC for touchscreen controller operation supplied through the 2 amp GTC1A circuit breaker on emergency FC1 and the 5 amp PFDB GTC1B circuit breaker on main panel 1. Either circuit is capable of powering touchscreen controller number 1. D4 protects the GEA circuit. It's on the emergency bus. For those of you who, like myself, may have trouble remembering what the GEA is and does, here's a refresher from the PIM. GEA 71B engine airframe unit. The engine airframe unit, mounted on the aft avionics shelf, processes analog signals from the fuel gauging system, airframe, and engine sensors, and transmits this data to the integrated avionics units. Quote, and for extra bonus points, here's another GEA function. Quote, in pulse mode, the GEA provides a pulse mode command to the landing light controller. This causes the wingtip landing lights to flash in an alternating pattern when the aircraft is above 500 feet AGL and the strobe and anti-collision light switch is on. Quote. D5 is fuel valve 1, an emergency bus circuit. This is named the fuel tank control valve in the PIM, and this is the valve that switches the fuel flow from the right wing collector tank to the left wing collector tank and back. Since there are 2 valves, let me mention now that fuel valve 2 circuit breaker is on the main bus, and it's at position F2 on the Copilot circuit breaker panel. Time for a quick SF50 Fuel System 101 refresher. Fuel valve 1 uses the motive flow ejector pump to maintain fuel pressure. When the electric pump is in use, the system uses fuel valve 2. So if you're down to BAT2 emergency power, fuel valve 2 and the fuel pump will not be powered, but fuel valve 1 will still be powered and will continue to switch tanks. Circuit breaker D6 is the landing gear indicator circuit. This is the gear up, down in transition light. This is an emergency bus circuit and will work even when you've lowered the gear manually. D7 is the bleed air shutoff. The PIM calls it bleed air PERSOV, or pressure regulating and shutoff valve. This, not the flow control valve we discussed earlier, is what controls the flow of the bleed air out of the compressor section of the engine. It is on the essential bus. And we control this to a degree in the cockpit using the bleed fresh switch. This valve is powered closed and it will fail open so we don't lose cabin pressurization in the event of a failure or loss of power to the essential bus. D8, cabin pressure 1. This is the power for the cabin pressurization control. It's on the essential bus, and recall from the earlier episode in our discussion that the cabin pressure 2 circuit breaker controls the outflow valve manual dump operation. Breaker D9 is engine IPS 2. We talked about engine ice protection in detail in the earlier episode, but and last but not least on row D is D10, Igniter 2. The PIM calls this Igniter 2 and the ignition control panel. I've already complained about the lack of documentation on the ignition control panel, so I'm not going to whine any further about it. So we now move to row E. Circuit breaker E1 is instrument lights. This breaker handles both the crew micro spotlights as well as the internal lighting for the bolstered panel switches. It is an essential bus circuit, so you won't have these lights if only the emergency bus is powered. E2 is ECS Control 1, and we discussed this breaker during the previous episode when we covered circuit breaker C1. E3 is wing and stab IPS. This essential bus circuit covers two systems, the wing and tail ice protection, meaning the boots, and also the windshield and radome ice protection system. But there is another circuit breaker at position E10 labeled windshield IPS that also protects the windshield and radome IPS circuit. The PIM labels this windshield radome ice protection 2. E4 is probe heat right, discussed earlier. The breaker at E5 is fuel level. Now the PIM labels this fuel level and ice protection level. As there is no explanation in the PIM as to exactly what this means, I'll hazard a guess and say that this is power to the circuit for both the fuel tank quantity sender and the IPS tank quantity sender, but I can't say that for certain. E6 is XM data, as in Sirius XM. It's an essential bus circuit, and the PIM says it protects the XM satellite and XM remote systems. E7 is oxygen crew, another essential bus circuit. The PIM goes on to say this, quote, the circuit breaker removes power to the valve on the oxygen supply cylinder. And it also says this, if electrical power is lost, the bottle shutoff valve is designed to remain in the last commanded position. Now, in my podcast on the smoke removal checklist, I discuss how important it is to know how to depower the crew oxygen system when shutting off the generators in BAT 1. Turn off Gen 1 and BAT 1 before turning off the oxygen master. This removes power to the valve and it'll stay in the open position. If you turn off the oxygen master switch first, well, you just turned off the oxygen flow to your crew masks. Circuit breaker E8 is engine ignition control. The PIM tells us this essential bus breaker actually protects the mysterious ignition control panel, the engine knob, and the Hobbs and flight hour meters. The engine knob is the two-position rotary switch with off and run. The ignition control is still unknown to me, and the Hobbs and flight hour meters are more or less obvious. But as a quick reminder, the Hobbs meter begins recording when the pilot turns the engine knob to run, momentarily presses the engine button, and switches either Gen 1 or Gen 2 on. BAT 1 must also be on. Now, since the normal checklist has you turn on both generator switches before actually pressing the start-stop button, I believe that the Hobbs meter will commence running when you press the button. It stops recording time when the pilot turns the engine knob to off and momentarily presses the engine button, which shuts down the engine. The flight meter begins recording when wheels are off the ground and the ground fan is off. It stops recording when wheels are on the ground and the ground fan turns on. Interestingly, the master MEL says that both the Hobbs and flight hour meters can be inoperative if their respective time, engine run or flight time, are tracked by alternate means. E9 is another easy one, the ice light. It's an essential bus circuit like all the other IPS systems. E10 is windshield IPS. This essential bus circuit protects the electrical components of the windshield TKS system. The PIM is not specific, but I strongly suspect this is the electric pump to get the fluid out of the tank and onto the windshield and radome. The windshield IPS is also protected by E3, mentioned earlier. E11 is emergency auto land as installed or not on your aircraft. The PIM has zero information on this circuit breaker and what exactly it protects. Finally, we're getting close to the end of the Copilot side circuit breakers. F1 is the avionics fan. There are several fans in the SF50, and the PIM says this about the avionics fan. Quoting, the avionics cooling fan is installed under the left-hand console assembly below the PFD. During system operation, the electric fan provides ambient air cooling directly to the integrated avionics units. This is a main bus circuit, and it cannot be MEL'd. If the main bus is not powered in flight, I don't know how long it might take for the various components to get too hot, and the PIM does not have any specifics. Interestingly, though, the emergency bus volts checklist says this about the avionics fan when operating on emergency power only. Quote, non-essential equipment such as avionics fan, and I edited out the other components for brevity, will be inoperative. So this tells me the avionics fan is not a supercritical piece of equipment. Since BAT2 is designed to power the emergency bus for at least 60 minutes, it seems logical that the avionics powered by the emergency bus can run for 60 minutes without the avionics fan cooling them off. The Garmin manual lists cooling cast messages for the PFD, MFD, GIA, and the GTCs, but they refer to internal fans for those components, not the main avionics fan. F2 is fuel valve 2. As with its counterpart, the PIM labels this fuel tank control valve. It's the number 2 valve, which is used when the electric fuel pump is on. We discussed this in detail earlier when we talked about fuel valve 1. Circuit breakers F3 and F4 are unused, and room for new systems, perhaps. Personally, I'd like to see a microwave oven and seat heaters, please. The F5 breaker is labeled AHARS 2 and ADC 2 on the breaker panel. The PIM says the same thing, AHARS and ADC 2. We discussed this main bus system when we talked about AHARS 1 and ADC 1. F6 is Iridium Wi-Fi data. Theoretically, this is an optional system, but I don't know of a single SF50 that does not have it. It's on the main bus. The PIM says it handles Wi-Fi data link and Iridium satellite. The Iridium transceiver provides satellite texting, sat phone, and lots of ground-to-air weather information. Rather than read it all here, you can find a long description on PIM page 19-17. 7 is IFE control, meaning the in-flight entertainment screen and audio. This main bus breaker handles part of the protection, and another part is handled by the IFE USB breaker on the aft circuit breaker panel. And last but not least is F8, the yaw SAS circuit breaker. This main bus breaker protects the yaw SAS servo. While we noted earlier in the discussion that the master MEL allows the yaw damper to be an op, the MMEL does not mention yaw SAS, so it needs to be operational for dispatch. Well, again, I hope your brain is not exploded. Mine's getting close. So let's wrap up this episode of Circuit by Circuit. The next and final episode will be short as we have only the nose and aft circuit breaker panels to cover.